Okay, so today we're doing a deep dive into a piece of what you might call invisible infrastructure. It's the Thor Broadcast F-1VD-TXRX kit. And our mission here is to figure out why a box designed to connect old-school analog video to brand new fiber optics is, well, why it's still so essential.
Exactly. It's really about the economics of it. You look at the application security, broadcast, digital signs. These are huge industries. They have billions invested in analog cameras and equipment that just works. This kit is the workhorse that lets them keep it.
So it's not about being nostalgic for old tech. It's about protecting massive existing investments. Its whole job is basically to take one channel of CVBS video, and it works with NTSC, PAL, SECAM, all the old standards.
Right, all of them.
Yeah.
And the really fascinating part, I think, is how it does it. The input is analog, sure, but the transmission is pure digital processing. And the spec sheet is very clear on this. There are no adjustments required.
Which is huge. You don't want engineers having to calibrate these things out in the field, I imagine. Just plug it in and it works.
That's the idea. It has to be simple. Because these things are often deployed in some pretty remote, tough environments.
Okay, so we've got the standards covered, but what about the physics of it, the fiber connection? It says here it works over single mode and multi-mode fiber, which gives you flexibility. But the distance, some models go up to 80 kilometers. That seems, that's a massive distance for an analog video signal.
It is.
Yeah.
And that's the #1 challenge, right? How do you make sure the video that arrives 80 kilometers away looks exactly like the video that went in?
Right. How do you avoid signal decay?
That's where the specs really start to matter. They sample the video at 10 megahertz, which is pretty solid. But the key is in these really tight quality metrics. They're what keep the color and brightness from getting distorted.
I see some of those here. Phase differential of 0.5 degrees and differential gain of 0.5%. For those of us not setting up broadcast studios, what does a 0.5% difference actually mean for, say, a security camera feed?
Okay, so think of it like this. Differential gain basically means the color saturation won't change if the scene gets brighter or darker. So that 0.5% means the colors on that remote camera don't get all muddy or washed out just because the sun came out. It guarantees you have, like, forensic quality footage. It preserves the fidelity.
So it's about reliability. And speaking of that, I see it supports blackburst for gen locking and synchronization. Why is that so crucial here?
Yeah, blackburst is like the heartbeat of a professional video system. If you have, say, a dozen traffic cameras all feeding back to a central hub from miles away, you need them all to arrive perfectly in sync. Gen locking makes sure that transmitted feed is timed precisely with everything else.
Got it. Okay, let's touch on the hardware itself, the operational side. These things are meant to run forever in some pretty rough places, and they sip power, less than 10 watts. And this is interesting. They can run on AC or DC power.
That wide-range power is a non-negotiable feature for this kind of gear. You think about a remote pipeline station or a cell tower. Power can be inconsistent. You're often running on DC battery backups. So that flexibility is key.
And I see here the system gain is unity, plus or minus 3%. So what goes in is pretty much what comes out in terms of signal strength.
It's the perfect digital bridge. It's not an amplifier. It's not changing the signal. It's just transporting it, perfectly preserved.
So that's really our takeaway, isn't it? This deep dive shows that foundational standards like NTSC and PAL are still alive and well. Not because of nostalgia, but because this kind of high-spec fiber tech provides this incredibly reliable, high-fidelity bridge.
And that really raises a question for you, the listener. When you think about this little box being able to send high-quality analog video 80 kilometers, what infrastructure do you see every day? Remote security cameras, old broadcast antennas, industrial monitors. Chances are, this blend of legacy signal and modern optics is quietly working all around you, more than you could ever imagine.